Planning and acting in the real world in artificial intelligence involves two main components, planning and execution. 1. Planning. This entails generating a sequence of actions to achieve a desired goal. AI algorithms, such as classical planning algorithms or more advanced techniques like reinforcement learning, are used to create plans considering the environment's dynamics and constraints. 2. Execution. Once a plan is generated, it needs to be executed in the real world. This involves translating the planned actions into physical actions, which may involve controlling robotic systems, interacting with sensors, or manipulating objects. The integration of planning and execution in real-world AI systems often requires robust perception, reasoning, and control capabilities to handle uncertainties and unexpected events. These systems are used in various domains such as robotics, autonomous vehicles, smart manufacturing, and assistive technologies. In real-world AI systems, time schedules and resources play crucial roles in planning and acting effectively. Here's how they are typically managed. 1. Time schedules. AI systems need to adhere to specific time constraints for planning and execution. This involves estimating the time required to generate plans, execute actions, and respond to dynamic changes in the environment. Techniques like temporal planning and scheduling algorithms are used to allocate resources over time effectively and ensure timely completion of tasks. Real-time systems often employ techniques such as real-time scheduling to guarantee that actions are executed within specified deadlines. 2. Resources. AI systems require various resources such as computational resources, memory, energy, and physical resources like robotic actuators or sensors. Resource allocation algorithms are used to efficiently distribute resources among different tasks or agents to optimize performance and meet objectives. Resource constraints need to be considered during planning to ensure that plans are feasible given available resources. Techniques like resource-constrained scheduling and optimization are applied to manage limited resources effectively. Managing time schedules and resources effectively is essential for real-world AI systems to operate efficiently, meet performance requirements, and adapt to changing conditions. It involves a combination of algorithmic techniques, system design considerations, and optimization strategies. Hierarchical planning, planning in non-deterministic domains, and multi-agent planning are advanced topics in AI that address complex real-world scenarios. Here's an overview of each. 1. Hierarchical planning. Hierarchical planning involves breaking down a complex planning problem into simpler subproblems organized in a hierarchical structure. This approach helps manage the complexity of planning by focusing on different levels of abstraction and decomposition. Techniques like task decomposition, goal refinement, and plan abstraction are used to create hierarchical plans. Hierarchical planning is useful for organizing and coordinating actions in large-scale systems or domains with multiple layers of abstraction. 2. Planning in non-deterministic domains. Non-deterministic domains involve uncertainty or randomness in the outcomes of actions or the state transitions of the environment. Planning in such domains requires techniques that can handle uncertainty, such as probabilistic planning or decision-theoretic planning. Instead of generating deterministic plans, these techniques generate plans that account for probabilistic outcomes and optimize expected utility or value. Examples of non-deterministic domains include robotics in uncertain environments, autonomous driving in unpredictable traffic, or scheduling in dynamic and uncertain environments. 3. Multi-agent planning. Multi-agent planning involves coordinating the actions of multiple autonomous agents to achieve common goals or objectives. This can include cooperative scenarios where agents work together, competitive scenarios where agents have conflicting goals, or mixed scenarios with both cooperation and competition. Techniques like distributed planning, negotiation, game theory, and coalition formation are used to address multi-agent planning problems. Multi-agent planning is relevant in various domains such as multi-robot systems, distributed sensor networks, traffic management, and resource allocation in decentralized systems. These advanced planning techniques are essential for tackling the complexity, uncertainty, and coordination challenges encountered in many real-world AI applications. They enable AI systems to plan and act effectively in diverse and dynamic environments.